Hi, my name is Daniel Blackburn, and today we're going to continue to talk about composting and especially now how to manage the composting process from the home scale to on-farm scale and up to industrial scale. We're going to talk about some of the parameters we discussed in last lecture, and now we're going to explain how to manage this composting process. Okay, so this is a follow-up on the previous lecture, as I was telling you just now. The previous lecture, we talked about the different parameters that are important and concepts that are important during composting, including the microbial succession, pH, moisture, and aeration, and how the air moves through the compost pile. All these concepts that we discussed in the previous lecture will be brought back now, and now we're going to discuss how to manage those and how to optimize those during the composting process. You can have a composting at the farm scale, at industry scale, or you have transported industrial waste or transported municipal waste. These types of how you will perform the compost and the decision making of how you will perform the compost will change a lot. So we already shown you two field visits during this course, one to Hiawatha, which I will link now here, and the other one to Al Haradi composting facility, which I will also link now. But these are large-scale composting processes with different sizes and different management of the composting process. But now, if you are given the job to operate a composting factory, what is your decision making? That's what we are going to teach you today. From the feedstock preparation up to the maturing process, how you will manage this composting process. So the most basic one we talked about in the last practical is backyard composting, home composting. Yeah. So backyard composting, you can do it hot composting or cold composting, but actually the majority of the backyard composting and the most appropriate way of doing it, as I see it at least, is the cold composting. Which means that the temperature is never rising up beyond 45 degrees. Yeah, it's only rising a little bit because you are continuously adding material to this compost pile. This is not something that you build this compost at once. You build it by slowly adding more and more material. So when you stop adding material, you have to wait for a maturation period, and then you can even remove the top layer of this compost pile and start a new pile and leave the old one to mature for sieving. So there's not much turning and mixing. Of course, if you do mixing and turning, they will help in the process because it will give more aeration. But as a general rule, the majority of the people, they do not turn their compost piles at home. They just accumulate a lot of waste and leave it to decompose, and then after the season is ended, 6 months later, they will just leave it to stabilize and then sieve or directly use it on the soil. So backyard composting is recommended, and one of the reasons we want to recommend this is because the decentralization of the composting process is really important. We want to reduce the amount of waste we are needing to transport up to compost facilities and up to landfills. So half of the waste at home scale is organic. And if you are able to recycle that yourself, it means it's a waste that does not have to be transported and recycled later on. So ideally, everybody could make their own composting and use it on their own garden. At least the people who are more conscious about the problem of generating too much waste, they can recycle that at home. And that's one of the most important thing that you can recycle at home is your organic waste. Yeah. Now, if you do not have a backyard, or if you have a problem of using that on a backyard, there are some things you can do to compost indoors. Yeah, and the main mechanism or technology that I like for indoor composting is vermicomposting, vermiculture, which we use boxes DIY. I will give you a lecture about vermicomposting because I think it's very important. And one of the best technologies for organic waste recycling is vermicomposting. But there are others. Yeah, there are others. There's the direct cold composting indoors. There is bokashi compost, which is very popular these days, but I'm not really a big fan of bokashi compost. I will explain in a bit. But vermicomposting for indoors is highly effective, and you can manage that really easy, and it's a lot of fun to do. There's a big community of warm composters worldwide, and you can link with other people online, and people are very happy about doing this. And I'm very happy about doing this myself. So I really recommend everybody that wants to do indoor composting that they move to vermicomposting. That is the best system that I can think of. The bokashi, on the other hand, the bokashi is based on is an anaerobic decomposition using lactobacilli. You have to introduce an inoculum to this organic waste, and then this fermentation will happen with the lactobacilli, and supposedly with the lactobacilli, the smells will be reduced and the properties will be increased. Otherwise, I find it that since you already have to do from the bokashi compost, you need to bring that to a soil afterwards and bury it on the soil. Why not do it directly, like in situ composting, like I demonstrated on the last practical? So if you have to bring it to the soil afterwards, the best thing would be just to do it directly in situ composting. I think it will be much better. But anyway, there's many people who are doing this, and every initiative for doing home composting and recycling of organic waste is highly valuable. Next scale is on-site and on-farm composting. If you are generating enough organic waste in your small industry, in your farm, and you are able to do this recycling in the site, that is always preferred. Yeah. So I've seen many videos, for example, even in jails or hospitals, people are using the food waste, for example, and recycling food waste on site, yeah, using vermicompost or other technology. But of course, this is just a little bit larger scale, and you have to consider a little bit more management. Most likely, you have to have hired dedicated personnel for taking care of this, depending on the scale that you are executing this type of project. At the farm scale, there is one type of composting which is very much valuable, valuable type of composting, which is the field edge composting. Yeah? It means that if you are removing a lot of organic waste from your plant residues, and the type of machinery that you are using is not appropriate for cutting through these plant residues in the soil, and you have to remove those plant residues from the soil surface, you can do the field edge composting. Just deposit all these materials on the field edge, and later you can redistribute these materials back into the soil when they are decomposed. Yeah? Nevertheless, if you can do the no-till system, it's an improvement over this. If you have the machinery that can cut through the plant residue, you can just leave this plant residue on the surface of the soil, and it will help in the soil conservation and the soil quality and biology of the soil in general. So this can be entirely substituted by no-till systems. But if you're not using a no-till system, you can do field edge composting, which is highly recommended also. The most popular way of doing compost, nonetheless, is aerated windrow composting. This is a larger scale type of composting, which means that we are building rows of piled up material, and we are turning this constantly or every few days. This is the same type of composting that we demonstrated on the field visits for the higher water Kala compost and the Al Haradi composting facilities. These windrow composting, they are highly advantageous for producing a high quality material, finishing the process in a very short time, improving the efficiency of this process, and it's easily manageable by having by using heavy machinery for turning this compost and moving this compost around. Yeah. What is the process? We already showed you before. This is a big line of what's called a windrow, and the organic matter decomposition happens through the microbial activity on this pile, where the organic matter is oxidized, and some of the oxidation of the organic matter leads to the formation of stable humus, which will be a highly valuable organic amendment for soils, which is called the finished compost. In the process, the microbes will release heat and there is loss of moisture. So you need to take care of some of these parameters to optimize the oxygenation, the temperature management, and the moisture content. It must be optimized to keep this process highly efficient and performed in the short amount of time. If you do not manage this well, you will have problems. And we'll talk about these problems right now. So aerated windrow composting, you can also have scales of this. You can have small windrows, which depending on what the machinery you have and the type of residues that you have, this can be easily manageable. The small windrows is more like what you've seen on Al Haradi composting facility in the previous video. This type of windrow, the small size of the windrow, is you recommend this type of system when your material have lower porosity, or has lower initial carbon to nitrogen ratio. If you have a low porosity or lower initial carbon to nitrogen ratio, if you make compost that are too large of a windrow or too big of a windrow, what will happen is you will create some anaerobic condition, you will have some odor problem with the management, and you may have some overheating also. So if you have a good porosity, a good situation on the structure of the material, and you have an adequate carbon to nitrogen ratio, what is really recommended is that you go for large windrow system. So here are the large windrow systems. You can build up this up to 3.5 meters high, usually between 2.5 and 3 meters high. 3.5 is quite a lot. This is maybe the maximum at the start of the windrow. But there are scales for this depending on the machinery that you have. You can do different types of aeration management. Normally, this is performed with compost turners like the one you see here. This is a very large one. It means that you have a high investment cost on these facilities, but nonetheless, these are ways of managing a high amount of organic waste and recycling this in record time. This is the most efficient way of doing it. And if you have problems with drying or or even too much rain in some regions, you can cover these windrows with some special materials that allow the air to flow through outside, but it will retain some of the moisture and will prevent some of the evaporation happening or the loss of moisture in these windrows. Also, you may prevent excessive rainfall to infiltrate it and creating anaerobic conditions. One of the problems you may have when you're doing windrow composting is leachates. Leachates, if you have too much moisture in the system, excessive moisture or excessive rainfall infiltrating, some of the percolation through the windrow may bring some more nasty organic compounds, and this could be a water contaminant. So it's highly recommended that if you have large operations of windrow composting, that you have a cemented patio where you can collect the leachates and remanage that, even use that back for the irrigation of the compost piles later on, or the treatment of that leachates is highly recommended to avoid that reaching aquifers and contaminating water courses. Yeah, in the compost sites that we've seen, these leachates were not a problem at all because of the type of material that we're using in the climate here in Oman is so hot and that the material dries a lot, and there's not a huge problem of generating leachates from the two facilities that we visit here in Oman. But in other countries might be a big problem, so you have to take that in mind to avoid contaminating waters with the leachate if that is happening. Another big problem that you have on large composting operations is odor management. Odor is happening usually because of anaerobic conditions, but some amount of odor is natural in the first phases of the compost. While you're turning the compost pile, some amount of odor will be natural. So the location of the compost facility must be subjected for regulation also, and must be considering the neighbors and the situation, because some amount of odor will be always happening. Of course, if this is excessive, you have a problem, and the problems are related to anaerobic conditions. So the feedstock calculation is the one important step. The type of aeration system that you have, the temperature cycles that you are observing during this composting process, all these must be managed in order to reduce the odors. Yeah, the porosity of the material, if it's not the porosity is low, you might have anaerobic conditions and you might need to manage odor. If all these things do not solve your odor management, then you have to implement some system for removing the odor. Yeah, the odor treatment system. Here is just a small image here of that you can have biofilters for pumping the air from you can have forced aeration. You can collect all the air that is coming through this compost and force that through some biofilter to remove odor molecules like methane and ammonia gas, for example. All right, so let's move to feedstock management. Feedstock management is thinking about what are the materials that you are composting and how the proportions between the different types of materials are distributed on the compost operation. You have to be very careful to set up a good mixture so your process will be as efficient as possible. So if you do not set up a good mixture of a good proportion of different types of materials at the start of the composting process, you most likely will have problem with not heating or overheating, anaerobic conditions, and odor problems during the composting process. So setting up a good mixture of feedstock, the feedstock entry materials on your composting facility is of paramount importance. But what feedstock influences here and what other things like the management of the process and the maturity of the composting are affecting, this is a table that will exemplify for you. Yeah. When we're talking about the total nutrient content, the type of feedstock is very important. So you cannot expect, if you're using paper, for example, or a high amount of sawdust in the composting process, you cannot expect high fertility from this. Yeah? So you have to keep in mind that the property of your end product, the compost that you produce, is dependent on the original quality of your feedstock that you are using. So all these parameters are highly affected, or salinity is highly affected, pH is affected by the composting process, and the stability of the humus afterwards is affected by the feedstock that you use. Nevertheless, this is also more affected by the maturity of the compost. The disease suppressive potential is affected by the type of feedstock that you use. Anyway, you can read this table by yourself, and you can see how feedstock affects and which things are more important: the feedstock material, the process management, or the maturity, with regards to different characteristics of the compost. All right, so we have a huge amount of different types of feedstocks. We already talked about this in the last lecture. We call usually the low carbon to nitrogen ratio as greens. This is an informal term for low carbon to nitrogen ratio materials. And the high carbon to nitrogen ratio materials are called browns. Yeah. Nevertheless, other nutrients are also important on this system, especially phosphorus. Yeah, phosphorus and potassium are very important, but phosphorus play a big role also. If you use materials with very low phosphorus, that might mean that you will have problems with the microbial decomposition of this material also. Not only the carbon and nitrogen are important, but other nutrients also. So what we are targeting here is that we have an initial carbon to nitrogen ratio between 25 and 30 to 1. Up to 35 is also acceptable. Yeah, 35 to 1 is also acceptable. So you will have usually some material which is low carbon to nitrogen ratio, the greens, and that material is what you really want to stabilize. That is the material that will quickly decompose, that will generate anaerobic conditions, that will generate odor, pests. The problematic side of the composting process is the low carbon to nitrogen ratio material. The browns, on the other hand, is what you want to use to stabilize the low carbon to nitrogen ratio materials. So the browns, you will have 35, 50, 100 carbon molecules per nitrogen molecule. So high carbon to nitrogen ratio in the browns, and you will use that to stabilize the greens on your process. Management of the aeration on the composting process. So it's very important that you have oxy conditions. You cannot really, let the carbon dioxide build up too much on the compost pile. Otherwise, the anoxic conditions will decrease the speed of the decomposition of the material, and also will cause this anaerobic process that will release bad smells, bad odors. So how to manage the aeration in windrow composting? There are different ways. The most common ways is having windrow turners, like the truck that you see here on this image. Yeah. So this windrow turner will come every 2 or 3 days and turn the compost pile, and by doing that, it will allow oxygen to get in and increase the porosity of the material, the structure during this composting. So the oxygen distribution throughout the compost pile is not uniform. Yeah, if you get the deeper you go inside the compost pile, you will have less oxygen. So what you really need to be concerned is about the oxygen contents on the middle of your compost pile, and if you monitor that with CO2 sensors. When either the CO2 or the oxygen concentration can be monitored. Here, the oxygen concentration, when it comes below 10%, you can turn the compost again, and then it will go up, and then you can monitor this and use this as a criteria of when to use the turning. The frequency of your turning process can be based on monitoring CO2 or oxygen on your compost pile. If you use the CO2, also you will be targeting between 5 and 10%. When it crosses the threshold, then over 5%, you will turn your compost again, and if you're monitoring oxygen below 10%, you will turn your compost again. So this aeration process is a way of keeping this process very active and speedy, and without having any problems with odors, bad odors in the system. There are other ways of doing this, and some other ways are more efficient, perhaps with more investment, or you need to spend a little bit more on building up the compost pile, but after that is simpler. One of the ways of doing this is the passive aerated windrow. How does that work? You put drains on the bottom of the compost pile. And as you put drains on the bottom of the compost pile, the air will move inside those drains because of the convective movement of the hot air inside the compost. The air will be sucked inside those pipes, and it will come inside the windrow passively. You do not need to pump. There is a big disadvantage of this method. One is you have to manage to move that material with those pipes on the middle. So the use of machinery on this situation is usually hard to perform. So the other disadvantage is that there is this uniform decomposition throughout the material. So there is one rate of decomposition more towards the middle than towards the edge, and usually how you manage this uniformity, this heterogeneity of the speed of decomposition, is that you cover the whole pile with finished compost. Because you have a finished compost on the top of it, you will not have a slower decomposition on the surface, and all the material that you want to decompose will be on the middle of the pile. So there is this this step of covering, of building up the drains, depositing the material, the mixture. The material has to be mixed well beforehand, because you will not be turning this with the windrow turners, and covering it with the finished composting. Also, it's an important step in this system. So all this complexity makes it that it's not really used so much. It's also, it could be cheaper if you think that you're not using this amount of machinery to be turning this compost all that much. If you just spend a little bit more on the start to build correctly this compost pile, it can be stay in the situation up to the end of the curing process. You just build it once and you allow it to mature all by itself, and then harvest it at the end by collecting and sieving this material. So overall I like this passively aerated windrow systems, but they are not used as much as with the windrow turning machines. Yeah. The other way of doing this is with forced aeration. Yeah. So the forced aeration is when you pump air through this compost piles. And if you pump air, of course, you will assure that the oxygenation will be at the highest level, and you will accelerate this process to a maximum. This air pumping could increase the cost of the material, and you can also use this air pumping to manage odors. If you treat the air that you're pumping out of that system, you can manage the odor easily. So it's useful for odor management also if you are using a forced aeration systems. Temperature management. Let's talk about temperature management. The temperature management, if you manage well the aeration system, if you manage well the calculation of the mixture of your feedstocks, what will happen is your temperature management will be straightforward, already accounted on this. We spoke in last lecture that the hot composting process will have the thermophilic stage, in which we call active composting, where there's the composition will be the highest. Between 35 and 45 degrees, you expect that the composition is very, very high of this material. And when between 45 and 55, this it's optimum. Yeah, it's optimum for the thermophilic microbes to break down recalcitrant carbon molecules like lignin, cellulose, for example. So when you do the hot composting, this thermophilic phase is it's helpful for the quality of the end product and the speed of the decomposition process. You will reach these temperatures if you have a good balance of carbon to nitrogen ratio between 25 and 30. And after this process, naturally the temperature will go down after the carbon molecules are consumed by the microbes. Naturally, the temperature will go down, and you enter the curing process. Yeah. So normally, if you manage aeration, moisture, the feedstock material, the temperature you will not regulate. You will not base your management of the thermophilic phase. You will not manage it on the temperature. What will happen is, if you cannot reach the thermophilic phase, then you might need to recompose the material, mix it again, because most likely you have a too high carbon to nitrogen ratio. Moisture management. The moisture management is normally not needed. The majority of the compost you do not need to irrigate. The moisture of the original green material will be enough for the composting process. Nevertheless, depending on the climate, or if you are using forced aeration, the compost might dry. And this is something we see here in Oman. So because of the climate, a very hot climate, and the material dries too quickly, and you really don't want that. You want to keep the moisture content between 40 and 60% at least, up to the maturing stage, up to the end of the maturing stage. If you leave the material to dry below that, sometimes below even 20% or 10%, the decomposition will be stopped, and you will have your compost will not be mature. If your compost is not mature, it might even harm the plants when you use them on your soil. So the moisture is highly important. And if your windrow turning system already has some moisture application mechanism, you can also use it to re-inoculate your compost. Yeah, you can use some microbial culture here, microbial inoculants, or even use the leachates to turn it back into the compost pile as a way of re-inoculating that system. And by re-inoculating that compost pile, you will even accelerate more the decomposition of organic matter, and some of the contents of recalcitrant carbon will be reduced. Yeah, reduced, like lignin will be reduced by 25% approximately in some cases when you use the inoculation. If you use inoculation, it will help. The practical experience for most sites that we see is they used and they stopped using because they find it does not change at all the quality of the end product or the speed of the decomposition. Nevertheless, some of the studies do point for some changes. So it's yeah, if you use it or do not use it, it's both are fine. But if you do use it, most likely will there be some benefit. If it's noticeable or not, it's hard to tell, but it's recommendable to use inoculation. The maturation of the compost is one important step, and so when the thermophilic phase ends, you need to leave this compost at a good moisture and good aeration condition. You do not need to turn this compost so often as you would do in the thermophilic phase. So you can not turn at all, or turn weekly or every 2 weeks, and leave it at least minimum 1 extra month for the maturation process after the thermophilic phase is ended. And how do you detect that the thermophilic phase is ended? Is because there's no huge differences between the temperature on your material and the temperature of the environment outside. So if your compost is still generating heat, that is the first sign that your compost is not mature yet. The other way you can monitor the stability of this is through pH. Yeah? So here's the pH. So when the pH stabilizes near the neutral situations, and that's when you expect that your compost is very mature. Yeah. So the maturing process, or curing process, it's takes from 4 to 8 weeks, minimum 4 weeks, and the majority of the composting sites, it's recommended that you leave at least 8 weeks. 4 will be the minimum, yeah? And that will depend also on the type of feedstock that you're using and the management that you are using in this composting process. There are differences between the properties of the mature composting and the young compost. Yeah, if you use a young compost, you can still use that compost on the surface of the soil. It's not recommended that you mix with the soil. But the mature compost will be a much higher nutrient content. You will have low risk of immobilizing nitrogen when you use it. This is the table of different properties between young and mature compost. Yeah, the risk of salinity is not really dependent if it's young or mature, but it's more dependent on the type of feedstock that you use. If you have more low carbon to nitrogen ratio material, then will be a little bit higher the risk of salinity with the compost. Yeah, overall, you can use this table and interpret by yourself. How do you test the quality of the end product of the compost? There's several tests that you can make. The jar test, where you add water to your compost and close it and leave it for a few days. If that generates very bad odor, this is a typical test that will tell you if your compost is stable and mature or not. The self-heating test, if you detect that there is some difference between the temperature in the compost and outside, it's highly important that your compost has the same temperature, very similar temperature from the outside temperature, or the air temperature from your facility. You can do also CO2 generation respiration tests to monitor that this has stabilized in basal respiration levels. Also, you can test the quality of this compost by germination tests. That's very important. And you can mix those composts with soil, and then you can test how it's changing the porosity, water holding capacity, organic matter content in the buffer capacity of these soils, and as a way of seeing the quality of the compost, seeing how the compost is helping your soils in these different parameters. So this is all that I had to bring for you today. I hope you learned something new, and see you in the next lecture.